Hello, chemistry class. It's Mr. Ng with a two-step molar conversion problem. Let's do part A. So it wants to find the number of molecules, and our given is 60 grams of dinitrogen oxide, N2O. So to do A, the first thing we got to do is we got to find the molar mass, right? Grams of N2O. We got to find the molar mass of N2O, which has 2 nitrogens and 1 oxygen. So each nitrogen weighs 14 grams, and each oxygen weighs 16 grams. So that's just 28 plus 16, which is 44 grams per mole dinitrogen oxide. Good. So let's find the molecules in 60 grams of N2O. 60 grams of N2O, so we're starting here. We want to get to molecules. So the path we take is we're going to go to moles, and then we're going to go to representative particles. You know, like always in Stoic, we always go to moles first. So let's get to moles, right? Does that make sense? Step 1, we're going to go to moles. Step 2, we're going to go to particles. So step 1, we're going to get to moles. Let's start with our given. 60.0 grams of N2O. Like always, we want to get out of grams and into moles. Grams of N2O, moles of N2O. Notice that these units will cancel. Great. 1 mole of dinitrogen oxide weighs 44 grams. Good. So all I got to do is divide. It's just 60 divided by 44, and I get 1.36 moles of N2O. Great, now I am here. So I just got to hop over to representative particles, right? So the next part, I'm going to start with my 1.36 moles of dinitrogen oxide. And I know that for every 1 mole of anything really, in this case N2O, I have 6.022 times 10 to the 23rd particles, in this case molecules of N2O. So let's just multiply across, times parentheses 6.022 to the 23rd, close parentheses, and I get 8.21 times 10 to the 23rd molecules. Good, of N2O. You know, usually in class we do it a lot faster. We do everything at once. So let's try that. So we're going to start with our given again, which is 60.0 grams of N2O. We're going to get out of grams and into moles, right? That's our first step. Our first step is to go to moles. That's our first step. We're going to go to moles. That's a mess there. All right. Step 1, we're going to moles, right? So we know that it's 44 grams of N2O for every 1 mole of N2O. That gets us out of grams and into moles. For every 1 mole of N2O, we have 6.022 times 10 to the 23rd molecules. So if you do that, it's all at once now instead of writing it in 2 different steps, but you should end up with the same answer, 8.21 times 10 to the 23rd molecules of dinitrogen oxide. Good. Okay, class, let's do another example of a 2-step conversion. Here we're starting with the molecules and we want to get to volume. We're starting at molecules and we want to get to volume. So we got to do step 1, get to moles, and then step 2, get to volume, right? Seems easy enough. And if you notice, I don't have the periodic table copied and pasted onto this slide because we don't need it. We're going to use the numbers 22.4 liters per mole to convert to volume, and we're going to use Avogadro's numbers 6.022 times 10 to the 23rd. these two numbers are independent of a chemical, so we don't need to look anything up in the periodic table this time. So let's get started. So we're going to start with our given. Our given is 3.24 times 10 to the 22nd molecules of neon gas. To get out of molecules, we're going to put it on the bottom. Molecule of neon. And let's put moles of neon on top. And we know that 1 mole of neon is 6.022 times 10 to the 23rd. Right? This is going to get us out of molecules and into moles. So now to get out of moles, so we just did step 1, right? Now we got to go from moles to volume. To go from moles to volume, here we have moles up here, so moles has to be on the bottom here, moles of neon. And we know that 1 mole takes up 22.4 liters. See that? Moles will cancel, and we're going to end up in liters. So if you punch it across, you should end up in 1.21 liters of neon. If you didn't get that, I bet you messed up somewhere here. So make sure you put parentheses around these numbers with the exponents. Make sure that you're dividing here, all right? In step 1, you're dividing. And if you just did that step on its own, you should have ended up with 0.0538 moles. Right? And then you just have to multiply that by 22.4. Makes sense? So, in these two-step things, we're doing what we've always done in dimensional analysis. We put the unit we went out of on the bottom, the unit we went into on top, and then, like always with STOIC, we go to moles first. Thank you very much for watching.